Okay, so given a table, tell whether the relationship between x and y values is linear. First, how do we know if something's linear? If a relationship between two values, two sets of data is linear? Chelsea? Good, yeah, if there's a constant increase in x and y. So like from here to here, my change in x is 4. From here to here, my change in x is 2. And here to here, my change in x is 4. Now, at first glance, we go, well, really, that's not constant. But we have to check out the change of y also. Here it's 8. Here it's 4. And here, 8. So when we combine the two and we just kind of look at them, we go, well, when I change 8 on y, I'm changing 4 on x. That would be a change in y over a change in x of 2. When I change 4 on y, I change 2 on x. Is that still a change of 2? Yeah. Okay? And then 8 and 4. All right, so is this linear? Yep, this is linear. All right. Tell your neighbor what we found by doing that. It's very true. We found that it's linear, and Jaden actually said the right answer. She just doesn't think she has. We have found the... Jaden? Yeah, we found the slope. The slope is 2. Remember, change in y over change in x. What else do we need to write the equation, which is what it tells us to do next? It says if it is linear, write the equation. Annalise? We need b. TT, any idea how we find b? Good, that's great. That's 2 different ways. Perfect. You could either plug in coordinates. We know m is 2, and then we can use an x and a y value. And we have a lot of x and y's here to choose from. So we could use like 2, 8 if we want, or 6, 16, or -4, -4. So I'm going to use 2, 8, 2 for x, 8 for y. And we can solve from there. 4 plus b equals 8, so b equals 4. Or as TT pointed out, you could just, if in your table they tell you what y is when x is 0, remember your y-intercept, if you were to graph it, your y-intercept is where it crosses the y-axis. Well, it crosses the y-axis when x is 0. So if we see 0 for x, this automatically tells us b. In fact, if I have a table and I'm looking at it and I see 0 in x, I automatically circle and I go, that's a y-intercept. Those are things I just automatically label in tables. Hey, that's a y-intercept. That's my b. That makes life a lot easier. We got 4 here, but we could get 4 just by looking there also. Okay, tell your neighbor what the equation is then. All right, Jake, what do you got? Okay, y equals, I'll start you. Y equals what?
Y equals 2x plus 4.
Yeah, man. 2x plus 4. Y equals m, which is 2, x plus b, which is 4. Nice job. Any questions? Okay, number 41 right now. I want you guys to tell your neighbor if it's linear. Yes, no, why not? All right, Toki. What do you think? Yes or no?
No.
No, how come?
Because it doesn't really go in a pattern.
Doesn't really go in a pattern, so when I'm adding here, I've got 3. And here I've got, what, 4? And here I've got 5. That's kind of a pattern. It's just not constant, right? So we want to look for a constant, but remember, it really depends on the change in y over change in x. So when we're comparing, this has to be, that's 5. This is, how much did we go up there, everyone? Crickets, man. Yeah, 9, yeah. How about here? 12. That sounded more like a bird or something, all right? So, remember, we're comparing this way, right? So 5 over 3. We good there, too? Yeah? 9 over 4. Are those equal? How do you know? Does 5/3 reduce? Does 9/4 reduce? No. If they reduce to the same thing, then they're equal, but these don't reduce. In fact, you put this on your calculator, you get 1.66666666667. Okay? And the 7 just is the calculator rounding. And then here you get 2.25. Did that in my head, dude. All right. So this is not linear, right, Toki? How come?
Because they don't reduce.
They don't reduce. The slopes don't reduce to the same thing. Hey, guys, you need to be able to explain why they're not linear. As Toki said, they don't reduce. Okay, they don't reduce to the same thing. That's a good point. Good job. All right, guys, I want you to take a look at the rest of that page. Try to finish that up today, and then finish up your warm-up. So if you haven't finished your warm-up, that's number 1. Get that done. We're going to go through that as a class, and then you're going to wrap up the packet by finishing up through number 50 there. Any questions? All right, make sure you ask if you need help.